Swayam Prabha. Digital India. Educated India.
All right, so we are meeting for the first class, and this subject is called the advanced textile printing. Now, why we are calling it advanced is we believe that some printing you have already done, and some new technologies which are there, or some topics which may not have been covered at the undergraduate level. So, those are the kind of things that we will be covering, and therefore, we are calling it an advanced printing technology. So, the important thing will be some of the content which has been described in brief. The detailed content, of course, is available. So, from the historical perspective, we will try to do a revision of the textile printing techniques and lay emphasis on little more emphasis on some topics and various printing styles and methodologies. And then we would of course have one topic. It's quite, I believe that most of you may not have done the transfer printing, which is not so popular, but is getting more and more popular, which would have its scope, printing inks, the paper, the machine, conditions, some of those things which we'll cover. And then the digital printing, which is also becoming now popular. It's because of the cost that we find that most of the machines are not available as far as the production is concerned. But people are getting into it, and hopefully next decade would be a different decade. So there, machines, the principles, various types of jet systems, the drop on demand, stability of inks, different classes of fiber, fabric, auxiliaries, etc. Pre-post treatment of the operation, and scale and economics. This is what may be interesting as far as course is concerned. So we start with the lecture 1 in the conventional printing. So obviously, as we said that some of you have done textile chemistry undergraduate, some of you have not, and therefore those who have not done, they will have to work harder in a different way to catch up with the rest of the class. But we will spend some time revising what you have done in the undergraduate, and also some of the topics which you may not have done, and we will discuss them as well. So, we revise what is printing. Okay, this is one important thing that we would like to know. What is printing? Essential ingredients in a printing paste, basic steps involved in printing, styles and methods. This is in terms of, let us say, the areas in which we will spend. So, before we take printing, let us try to revise, and you will help me. What are the basic unit operations in chemical processing of textile, the whole gamut starting from the grey fabric to the finished fabrics? So, what would be the first process?
Grain inspection.
What do you say?
So grain inspection.
Inspection. Well, that's an inspection part of it. There is not really much of a preparation. Good. Any other?
Shearing and cropping.
Shearing and cropping, which probably may have some similar operations of this type. And why do we do this process?
Remove protruding fibers.
Right. So, we remove protruding fibers, and this process is quite important from the point of view of printing, because when you have lot of protruding fibers and you do a printing by any method, there is always a chance those fibers will also get some paste, and when you lift a roller or a screen, they may also jump, and when they jump, then they will do something which you don't like. And so from printing point of view, it's a very important process. And what is the next process? Okay. So why do we do desizing? Remove size. So this is a necessary evil that we do, which is called sizing. This has nothing to do with the natural. It's a man-made problem which has been created, but it was important for them to do that. And so various processes, whether enzymatic or non-enzymatic processes, are used to remove the material that you have added during the preparation or during weaving. And then scouring. So this scouring is not for every fiber as such, but every fiber will have a different reason for scouring. Cotton probably is one of the most important ones, which requires a lot of scouring. Why do we do scouring?
To remove oil and fat material.
So you have various oil, fatty materials in the thing, and you would like to remove so that the next processing becomes good. And one of the reasons why you are looking at it is the wettability of the material. So you want to increase the wettability, because whatever chemicals that you want to add, you want these chemicals to diffuse into the fiber and then do proper reactions and proper bond making, so that you get either dyeing or a chemical finishing or whatever. This will be good if you do scouring. How do we test whether the scouring is good or not? Right. So you can put a drop of water on the fabric, or there are tests which are sinking tests and so on and so forth, which can tell you as to scouring is good or not. Next process could be? Right. So when you look at bleaching, again this bleaching is also different for different kind of fibers. I mean, you're looking at cotton as a thing, but if you have wool, if you have silk, you have polyester, if you have any other kind of material, so you will be looking at different kind of bleaching agents. Most important bleaching agent is? Alright, so this is called the hydrogen peroxide. So oxidative bracing agents are there, which you will use depending upon which fiber that you have. Next. All right. So if you look at mercerization, this is also very, very specific to only cotton. If you have other fibers, let's say viscose, do you do anything? You don't do anything, of course not mercerization, but there is a process called causticization, right? So which also is important for diffusion of chemicals into the fiber. And so, but mercerization is specific to only cotton. Can you mercerize wool? Why not? So it will just get destroyed, dissolved in the alkali. Even mild alkali can dissolve. This is too strong an alkali for wool, silk. And therefore, this process is very specific. So when we talk about unit operation, so every fiber will have a different unit operation, right? It's not that one single thing is going to work for everyone. And then of course, dyeing, which is most interesting unit operation, which adds a lot of value. Now, most of the people who are sitting here, or you meet them, there will be very few who wear only white, right? So they get identified. But large number of people would be wearing some colored clothes, and the dyeing becomes an important part. And so all things related to the chemistry of the fiber, the chemistry of the dye, their interaction becomes important. And so we would like you to remember, you will be doing some course in this. And then we come to our topic, which is called printing, right? One of the most important unit operations, because it adds a lot of value. And finally, a finishing, which also is a general term, different fibers, different finishes, and itself is a big area in which various types of functional properties can be imparted in onto the textiles. So let's say we are going to be concentrating on printing. This is what the thing is, and that at the moment we are looking at conventional printing. So value addition, as we said, that unless and until you see color, the customer would not like to touch anything. You go to a shop, when you start looking at it, you look at the colors and you get impressed by them, and then the one who has made it asks for more money. So the value addition happens quite a lot when you do printing, and depending upon what kind of print, which is a personalized print, then obviously the value is very high, only for you. And if it's a mass produced print, then obviously the cost is less, and therefore the value also is less. Therefore, one is looking at printing as an operation coming to all the unit operation that you saw. This has to be right first time. There is nothing you can say, well, doesn't matter, we will try to repair. When you do something in the wrong in the dyeing, that is, say, the depth of shade that you wanted is less, so you can top it up. It costs, but you don't have so much of a wastage, you can top it up. If you find the depth of shade is little high, you have a stripping mechanism, so you can strip it up. If you find the errors are too many, then you can say, well, I'll do another dyeing with deep shades, dark, black, blues, reds, and suddenly you will find, well, the value can still be recovered. You can't do in printing. If you've done something wrong, there is no way you can correct it. You can't take a brush and start doing something, right? This is therefore a difficult, printing is a difficult unit operation. It's not easy. Finishing, first of all, people can't even find if there is a fault. Let's say you are doing a wash and wear finish, and how can anybody find whether the wash and wear finish is very up to the mark, or there is a variation, or there is something else? Just go. The complaint will come after 1 month, by the time thing is gone. But not that complaint should come, but right first time, every time is printing. Any textile operation, starting from making of a fiber to the making of a yarn, the variations are there and people accept some variations. This is okay. But if you do something wrong, you say, okay, it's going the seconds, it's going the thirds. If you make this mistake here, the chances are there will be nobody to pick up the thing, and that's a real loss. There is no correction that you can do. And this is difficulty. If non-experts can find your fault, then you can't sell it. In many other things which are, let's say, finishing, which adds a lot of value, non-experts can't tell you what is the fault. Here they can tell, because there is a design which looks like a design. There are many colors there, and so if one color goes out of its boundary, people will know it's come out of the boundary, because you did not set it properly, you could not print it properly, and that's it. And you can't correct it, so you have lost the value. Just like that. So the difficulty levels are others also. In dyeing, for that matter, dyeing is also something where people can find some fault, but not like printing. As I said, we can correct it also. In this case, you actually use more than one color. So when you say that I am printing, so you're not talking about one color or one shade. So you have more than one shade, same green but different compounds. And so, getting to many things in different areas of the fabric and hoping everything will be fine, and you say, I want to match the shade. How do you match the shade? You will get the result only after you have completed the printing process. Till the time you have not completed the printing process, there are many ingredients around. They themselves play various role in showing you what color you are seeing. Becomes very difficult. The shade matching, let's say computerized color matching systems are very nicely, beautifully used for dyed material. For printing material, even if you get a shade, well, this part of the green is to be like this, that part of the green must be that, red must be this, and the blue must be that, and all of them must match. It's a very, very tough thing. And therefore, those who actually handle the printing department are really big names. They are really good experience. They understand when the fabric is running at 50 meters per minute and they can find a fault and they say, stop the machine. Something has to be done. So, it's a very serious business. As I said, non-experts can tell you, you are wrong. And fastness, which fastness are we talking about? Every time we talk about a shade, this shade has been made by mixture of dyes, not one single component. And when you mix, you can make errors there. When you choose the mix, this time you had one type of dye, a green, the other type, another type of green. They're supposed to be similar, but they're not same. Okay, so you match them. But even if you match the shade in your own, from your own perspective, then what do? You like them to wash fastness. All the dyes can give you the shade, but they may not have the same wash fastness. So, when you have a dyed material or maybe from a single component dyed material, when you wash, something goes out, the shade may keep decreasing, depth of shade may go going down, but you may still be able to survive, because most of the time you will not remember what was the original shade. Even lab of course will know. In this case, something which appeared to be a particular type of a blue is now a different type of a blue, because one of the components gone more, other is still there. The mix is changing. Similarly, when you look at a light fastness, one may be fading faster than the other. So, what you see is a change of tone happening. A change of tone is much easily identifiable compared to the loss of depth. And so, it becomes much more difficult. The selection, which dye has to be selected, how it has to be applied. So, you are looking at a fastness first, you are looking at a light fastness first, you are looking at a shade first, then you want to match the shade. And then you also find if you make a mistake, somebody will find out. I mean, it's very difficult. So, you must appreciate any product which is a printed product and actually you are liking it, then somebody has worked very hard. So, as an engineer, you should appreciate almost every product, but I am now telling you a printed product is definitely something which you should be proud of and should appreciate and thank the guy. It's quite possible. The people who head the printing department may be actually getting higher salary, at least in the private sector, compared to the finishing guys or the dyeing guys, simply because if they make mistake, company loses straight. So, they have to be right, and so you right kind of people, they accept. Of course, experience is the one which helps. Now, let us say whatever somebody said is printing. Of course, we understand at different points something is happening. They call it sometimes localized dyeing. Printing itself is their term which we are trying to understand. You say now it is like dyeing. What is the special thing about dyeing? How a fiber gets dyed? How does it get dyed? That is the most important thing. Dissolution. So, important thing is dyeing is a process where a dye particle must get dissolved, get into a molecular form so that through whichever medium, could be aqueous medium, goes into. So, you can't dye with solids. Particle cannot go in. The size of a particle is too large compared to the space that may be available for diffusion. But if you get into the dissolution part of it, you can dissolve it any solvent, let us say water, then it comes in a molecular level and then it goes. So, in printing also, something like dyeing must happen. Otherwise, printing, as you know, happens from a paste. Paste has a very high viscosity, and based on the kind of a dye, the concentration may be different, but it still must act like a dye, unless of course we are dealing with pigments. The pigments, you know, don't go inside, they stay out. You have to use something else to fix them up. But when you say dyeing, that means this product, the material has dissolved, and in a molecular way it has gone inside the fiber. That is one interesting thing. Therefore, they call it dyeing, right? Otherwise, you could have just kept it printing. Yes, the process is printing, but what is happening is dyeing, and therefore, the chemistry of fiber becomes important, the nature of dye becomes important, the fiber and dye interaction becomes important. So, everything is important. So, whatever you are doing in dyeing, you have to do anyway. Like you will choose the dye based on the fiber. Something else of course can also be done. So, let me just say, because we are still in this topic, on this topic, a small calculation. This is not to check your mathematics. Can you just tell me, if I want to dye a fabric at 2% shade, you understand what is a 2% shade? You see, 2 grams per 100 gram of fiber, that is the kind of thing, a 2% shade. So, you dye it from a dye liquor, you know, we express it, let us say the concentration grams per liter. So, let me see, in an exhaust process, okay, you understand what is an exhaust process? Everybody understands? So, an exhaust process is where you take the fiber and the liquor and keep working on it till you believe dye has gone from solution to the fiber. The bath has exhausted, and then you stop the dyeing and get out of it. So, what will be the concentration of a dye liquor in an exhaust process when you want 2% shade at an ml ratio of 1:50? Can you calculate? You are looking at the concentration of a dye bath. Simple calculation, but I would like the value. What do you think is the value? Should not be difficult. So, we are looking at finding the concentration of a dye liquor when we want 2% shade at an ml ratio of 1:50. Very difficult? Give me some figure. Let us see if the figure is right or wrong. No problem. So, you are taking too much time. Anyone has come up? Difficult. Because if you do not know this, then you can't dye it anyway. So, you have to know how much dye has to be added in the solution so that you get a particular result. Things can still go wrong, but at least the start must be right. Anybody? You got some value?
0.4 gram per liter.
0.4 grams per liter. Right. So 0.4 grams per liter is the concentration. Let's say in the other process, which is called a pad process. So what you do in a pad process, you have a dip and a nip, padding mangle. You seen that padding mangle? So in a pad process, what will be the concentration of the dye liquor if I want the same thing at 100% expression? So we want the result the same at 2%, and we are looking at the padding method. Approximately, we are believing that the expression is also 100%. So some constraints are, some constants are with you. So let's see some value. Let's see who comes first. You do understand the terms, no? When you say 100% expression means what? What do you mean by 100% expression? If you know the meaning only, then you can say, oh no. Do you know the meaning? Who knows the meaning of a 100% wet expression?
If the fabric weight is 100 gram, it would absorb equal amount of water.
Right, or solution. So you take a 100 gram fabric, after padding it will become 200 grams, right? That's what is 100% expression. So what would the concentration of the liquor when we really want only 2% shade? Shouldn't be that difficult. 20 gram per liter. So this will be 20 grams per liter. Did you ever think that this kind of a concentration differences will be there? What is the order? You can see that? Order. So much of a difference in concentration. In printing, if you want to calculate, in that such a small area, there is hardly any water, because after printing you are dried, and then what are you doing? You are going somewhere to fix it, and what fixing? Maybe it's a steam in which you are fixing, maybe it's a dry heat, and what are you dependent on? You are dependent on something called a urea or any other material which absorbs water from the environment, not from solution. So what concentrations will be thinking of? Will an order or more higher. The concentration of so-called dye liquor in a so-called localized dyeing area, the concentration is very high. It has advantage. Advantage is when you have high concentration, the difference in concentration is high, then the chances of transfer is also quick. When you have equilibrium, nothing shifts, this one goes in, the other one comes out, so they remain equilibrium. But if the potential difference is very high, the concentration difference, then the rate of diffusion also is high. So we expect all these things to happen very quickly also, the diffusion. And so highly concentrated solutions, they get generated only when they are supposed to diffuse, otherwise they are dry, right. So in that sense, printing is a different one. So all calculations that you would like to make, what shade, what not, it will depend on what have you done. And how do you calculate? How do you calculate? In a case of dyeing, you had the whole fiber which was dyed, and what is here? Do we dye? Do we print? Or in a localized dyeing system, do we do it uniformly? Do we do it uniformly? So what do we mean by uniformity? Uniformity of what? That's the question. Of what means? There is a green here, then there is another green here, and there is another green, this is repeated. All that flower pattern is repeated. So you expect this green to be equal to that green, to be equal to that green, is fine. That's fine. At least nobody should say, well, I thought this was this green and now some other green is coming after every meter. That uniformity you will expect. That's the technological part. Hopefully the machines will be able to do that after proper setting. If you look at the printed fabric take the fabric, take the cross section or the fiber and take the cross section, do you think the fabric or the fiber across the cross section has been colored uniformly? Yes or no? No. So, if it is not colored properly, that means it may have penetrated 50%, it may have penetrated 75%, it may have penetrated 25% in the diameter part of it. Then how do you calculate the shade? It is what you see, but what you see from the same recipe could become different if you change the time of steaming, and suddenly you find, oh, everything was same, shade is not matching because something else changed. Equilibrium is not reached. Equilibrium can be reached only if the same print is seen on the other side. The face and the back of fabric. Do you think any printed fabric's face and the back are same? They are not. So, even defining that this is percentage shade is a question. How do you define? You do not even know the weight of the fabric. You can measure it, but you do not know how much it has penetrated. If it penetrates 50%, shade will be different. If it penetrates 100%, shade will be different, although you have applied the same. That is the difficulty. So, you keep a lot of things which are not in your control, but you want to control and you must control, and that becomes the difficulty level of the printing. So, it is not an easy process, it is definitely not an easy process. And so, when somebody says, well, I have done some print in my lab, after washing, I am not sure you would ever like to wear that in the first go. And what is the question of is uniformity? At least from the face to back, uniformity is not needed. You do not want to print the back of the fabric in any manner, it will never look good, and so you do not. But you have understood the difficulty also. Then we say localized dyeing means you have to have boundaries. So, you have to make sure that particular color is only in that boundary, it does not go beyond. What have we done? We have done covering, we have made more wet, material wetting properties have been increased so that things can go. So, theoretically we do not expect when you put a drop of water it goes only across the fabric, it goes around the fabric also, it goes in all directions. How do you restrict that? So, you say, well, we will be using highly viscous material called a paste. So, as long as very highly viscous, it will remain there, then you dry it, it will remain there. Only when you are just about to say, well, it must diffuse, give certain amount of moisture, little bit of a dilution, and then it diffuses. So, you are hoping that it is concentrated, it is very small amount and very less amount of water, that means high concentration. Therefore, you do the control the spread. It is very important. If everything is right, the person had printed very nicely, everything was in the right place, but when it was getting fixed, something started diffusing, yellow going into the blue. So, you have another boundary of a different color which you never wanted. So, somebody will find out or not, finds it out or not is a different story, but the person who is doing the job is very unhappy that after all the hard work what you get is the wrong design. So, in this printing process, of course, you have to print and then you have to dry and fix. This is the most important step. All of them are very important steps, You make a mistake anywhere, it is all over. Drying, of course, you may have some leeway that you are just drying, removing the moisture, but you can, during drying and handling, if there is a crack appears because you have a film of a thickening agent which has been dried, then the moisture penetration through the crack will be different, and you might see after print you actually have a permanent mark which may not get fixed properly. So you have fixation, which is important. You can do dry, steam. So these days your steam also is atmospheric steam or superheated steam, so high temperature steam. Any of them can be used depending on which fiber, which dye combination you want. And then you wash. Obviously you have to wash because you have added so many other things, which we'll see, which were not part of your plan. You wanted only dye, but you have a lot of things. Wash and then dry. So drying, fixing, like any other chemical processing unit operation, a lot of energy is consumed, but that's it. No problem. We have to consume energy. Unless that happens, it becomes a problem. So this is the basic process of printing a textile fabric. Simple steps. Essential. We've done everything and you say now washing. Washing itself is a difficult task. There's so many colors very near each other, they are now going to come out. The question is, it's a very unlikely that 100% of all the color that you have added have gone into the fiber and they are also fixed exactly in a manner in which you want to fix and nothing will come out. Then the best thing. But that doesn't happen because every reaction is an equilibrium reaction. 90% on the favor of fiber, 10% not in the favor of fiber, or maybe 95-5, it doesn't matter. But whatever is unfixed is one will be washed, which will not just be the thickening agent or the auxiliaries which will come out, but the dye also comes out. The blue flows over the yellow flows over the white, and so anything can happen during this process. So you got to be very, very sure. When you do dyeing, you just wash. Just keep washing till everything has come out and you say, well, now nothing will come out. Go ahead. The same thing you want to do it here, but you have to be very careful. The moment the dye comes out from any region, it should not go back to the fiber at any portion of the fiber or the fabric that we mean. And so washing is a tough thing. So everything that you want to do in a printing is a tough thing. Although it's a simple process: print, dry, fix, wash, dry. Well, then there are fun things also. The fun things are that you can print in different ways, and they are called styles. And these three names must be in your mind: the direct, discharge and resist styles of printing. So what's the direct style? Yeah, somebody will tell me. What's the direct style of printing?
Color onto the fabric directly.
Right. Like block printing. What do you say? Like block printing?
It can be block or screen or rubber.
Right. So that is the technique of applying color. But this is a style. So what it means is that you have a fabric. On this you are putting some design. Color could be different. Yeah. So whatever the design, you print it on the fabric, right? That's one. You can have 4 colors, so you'll have 4 different times you have to work, so that 4 different colors and 4 different parts of the design become the main part, main design. Can we print with a direct style on colored fabrics? Yes?
Yes.
Good. So it doesn't matter, it's a white fabric, grayish fabric, yellowish fabric, bluish fabric, you can just print directly if that is what the design is. Suppose you have dark black, jet black fabric and you want light lemon print on that. What will happen? It may not be visible at all. So this style becomes relatively ineffective. And if that happens, then we have the other style in which we say, okay, we have a colored fabric and colored fabric generally deep dyed. If it is a light color, people would probably go for the direct style and you get the same design. If it is colored fabric, then you say discharge style, and what does it mean is that from the colored fabric you are going to be removing color from the design. And how do you do that? You destroy the color by, could be anything, generally reducing agent. If you take a reducing agent and therefore you have to select a dye, and I suppose you said I have dyed black with a wet dye, do the discharge for me. Will you be able to do that? No. Therefore, you get restricted. You get restricted that the dye which has to be discharged must be dischargeable. Only then you can use this style. Otherwise, if you work very hard, of course you can take an oxidizing agent to work very hard, then bleaching, I'll make sure that there is no color. You might find the fabric gets damaged. Any other thing can happen. And so, normally we'll choose dyes because therefore you must know what is the design and what is the things that are going to be used. Accordingly, you will choose the thing. If suppose somebody is adamant, no, in this style also I will like to use direct style, that means I am not going to discharge. Can you do that? Deep black shade, light lemon to be brought in, small dots, polka. Would you like to do that? Can you do that? You cannot, but you can. You can do that. You may not like it. What it means is that you print both. Print the small, then print the big. You can still get two prints, two screens, but printing is costly. Printing is a costly process compared to dyeing and then discharging. So that's one print type. In this also, you can have white discharge or a color discharge. It's up to you. But then again, selection of the so-called colorant has to be very specific as to one which resists the discharge, the other actually gets discharged. Important thing is, when we say that this is what the process is, this is only principle. The selection of a dye and a process will still be a tedious task. Then you say I have discharged, you say it is not as white as I thought. Then you have to do something else to look so that it looks whiter. So it's not something which you say, well, this is it and end of the game. It actually starts from here. In the resist style, which are quite popular, even before a lot of things were done, you do the reverse. And that also sometimes you may like to do the reverse because some of the patterns it may be difficult. For example, there is something called batik. So, irregular patterns to be created. So, you do something and then dye on top, or chemical resist where you print in a manner that the dye cannot get fixed. So, invariably you may be able to get like tie and dye, total mechanical thing. You get beautiful designs. So, chemical, mechanical resist systems have been developed for various styles and various kinds of designs which can fall in the category of resist style, right? Like what you said. So, what he was talking in the beginning of this small discussion was the methods of printing. You can use any method to adopt any style. Method would depend again on whether you are doing high production, low production, automated systems, or just simple things. So, I was talking about block. Yes, there is a block printing method, batch wise process. One can think of automation in blocks also. One can have a machine which can have blocks and print and this moves and then you print and that moves. You can do that also, but generally people are doing hand block printing, some traditional stuff, but you can do all kinds of things. Roller printing becomes a continuous process where the design is etched on the roller, and now it doesn't matter whether you discharge or a resist or a direct, it doesn't matter. Style is unimportant. It's a costly process. Generating a roller, design on a roller is a costly process. Screen printing is one of the most popular things. You can have a flat screen, or rotary screen printing machines. The flat would be considered as semi-automatic systems, or could be completely manual, and rotary is generally continuous process, where like a roller printing, a rotary screen is a continuous process. And of course, there are many things that you can do, like a stencil. Take a stencil, paint it the way people keep painting things. You will get a design. You can do spray. You can get the things. So, you can actually look at many other methods, and these days the kind of methods that again we will be talking, the transfer printing is a method. You do some printing somewhere else and then transfer onto textile. All the things have been done somewhere else and then you transfer. Or now we are looking at digital printing. So, all those things will be also methods. Transfer, digital, they are methods, and these methods are in some way fascinating to begin with, which are different from whatever is being used, and so we will spend more time here. I think today we can stop here and then we'll take up later the other aspects of the conventional printing, which are as serious as important as it can be. Thank you.